for example, I bought some Bluebell almonds at an airport, and then I compared them to the nuts.com almonds, and they were just like the nuts.com almonds were bigger and better. And so anyway, eat healthy snacks, nuts.com, great. Thanks for
Looks
joining
like
my
you've gone
inquiry.
nuts for nuts.com.
Yeah. So um, I was out of town for a few weeks, so I'm kind of doubled up on shipments. I didn't cancel one because I was like, they'll last a while, and they do. So anyway, I even have more. I couldn't carry them all, but
So, nicely sized for travel too. That's something I definitely do when I'm on the road is
and you
nuts,
could
dried
get
fruits, all manner of stuff that TSA approved.
nuts.com has it all, and you could get other sizing. So like you could get whatever you want at whatever cadence. It's beautiful. I'm doing this thing in my life right now, and then we're gonna get started. It's 101, where I'm doing what I'm calling my random weeks and then my structured weeks. I need a lot of structure in my life. Oh, this is all recorded. Shout out to the recording. Yo, you're getting deeply insights. Anyway, I signed up for, I'm in a meat club. So I get like a meat CSA, so a local butcher
Nice.
shop. But it's random. I never know what I'm going to get. And then the next thing I signed up for was this thing called Misfits Market, which is just random grocery store items that they wouldn't sell because they are not beautiful enough to be sold in a supermarket. So now I have like a week where I get random meat, random vegetables, and then the other weeks it's like very structured. I know what I'm getting at the store. So anyway,
Love
welcome to
it.
my
Love it.
insanity.
The future is already here. It's just not widely. Uh, but yeah, no, it's great to hear about all these channels for getting amazing food at whatever cadence or level of freshness. But the fact that you have that option is incredible. And yes, we are recording, but this is how we do. Hey, Lee, I just really want to say thank you so much for doing this. This an earlier iteration of this deck came across my virtual desks, and for us in professional services and training future GitLab admins, this was very relevant. And part of our goal is that we're growing with our customers, and we want to iterate our training content to kind of match where they're at and where they're going. So this definitely felt in that vein. So I will hand it over to you because I know there's an intro in the deck itself. There are notes as part of the calendar invite. I can help take notes, and Lee, it's all yours.
Great. What I'm going to say is if you want to throw the notes link in the chat as well, I'll pull it up on my other screen. So if you all have any questions in there, just put them in there and we can kind of, there will be some breakpoints where I can open up the floor for questions as we work our way through. And then from there, we'll see what we have. And just to confirm, I don't recall, do I have the full hour?
Yes, you do.
Okay, great. All right, team, I'm going to share my screen and give me a thumbs up when you can see it, and then we'll go from there. All right, golden. So this is GitLab debugging techniques coming from a support engineering perspective. I joined GitLab around version 8.15. I've been pivotal in trying to grow our support engineering and efforts, future and further efforts to what we're calling data-driven decision-making for all of our support. We want to base our decisions on data as much as possible, and these are some of the things that we've learned throughout this journey. It was birthed by a customer's request that it gave us this framework, and I think it's going to be a great resource to share with other customers as well. The first thing that we're going to start out with is thinking about common problem areas, and we're going to walk through them specifically with GitLab, the app. And the first one we're going to start with would be unicorn errors. Unicorn is a huge component of GitLab. When we write code for GitLab, the majority of the code we write is written in Ruby, which runs on Rails. And when you deploy that into a production environment, that is being served by Unicorn. Now, the three things that we want to pay attention to would be production log, Unicorn standard error log, and the workhorse current log. And these are a couple of things that we'll dive into as we go through this deck and we'll think about. And what I want to move into is kind of take a break to look at the architecture of GitLab. GitLab in its current form is huge. And I always describe GitLab as the collection of software and services that give you the GitLab experience, right? It gives you that end-to-end experience. It is not, we do not write all of it. We glue a lot of it together. We write most of it, but a lot of it is leveraging open source and other community standard tooling and protocols. This diagram comes from the GitLab architecture overview page. If you haven't been there, you can come and see this page here live. This is an incredible resource that we're trying to make even better. I want to make these elements clickable, but if not, if you come to the sidebar, you can click on Nginx. It will take you right to telling you about where in our docs and things you could find it, how we describe it into its, is it a core component or monitoring, and a little bit of description about what that does. So if you're ever, if a customer's ever asking questions or you have questions about, well, what the heck does, Redis do? If you come over to this sidebar, you come to Redis, you can see exactly what Redis does. And Redis is stored, we store session data, temporary cache info, and background job queues. Boom, this is a Bible. So just jumping into itself, when I talk about the first section of GitLab where a lot of errors occur, that would be Unicorn, which is highlighted with this arrow here. Now, this is because Unicorn does so much heavy lifting. Unicorn is a huge component. It gives you the UI. It is handling a lot of database interactions. It is basically the heart of GitLab. If that is faltering, you're going to see the ripple effect happen into other places. I also mentioned workhorse, which is right here. Workhorse sits in front of Unicorn. That was a technology developed in-house by us with the intention that when Unicorn is slow, a workhorse should be fast. So we put it in front of Unicorn to give to free up some of the resources when Unicorn would struggle, and that helps us move faster. To be very specific about what Workhorse does, there are subsets of requests. You could see Workhorse going straight to Gitaly and doing some other routing. Workhorse can skip Unicorn completely for certain types of requests when you're doing HTTP cloning and whatnot, so that you don't have to talk to the Rails app and you can be faster. So that's where Unicorn sits in. And like I said, oh geez, it's gonna do this to me today. There we go. Come on. Unicorn itself is the core, the heart of GitLab. I'm going to take a step forward and talk about debugging Unicorn and a few bits there. I want to pause and say, based on what I've said, any questions now, anything come to mind? I'm going to see if I can open this doc in another window on another screen, but it might not happen. So, any questions?
Yes, this is Mike Lindsay, a professional services engineer. The diagram's great. Do we have a diagram that maps this to our HA architecture? Like when we start splitting all these services out, where these things end up at? Like, you know, I know we see like the Unicorn and the Gitaly, but what about like say the Symfony, the LDAP, all that kind of stuff? Like where that goes?
Sure. Thank you, Mike. Great question. That diagram is in progress because there's a couple of different variants there. And as well as thinking about how our HA solution has evolved over time, the diagrams look subtly different. I gave a response yesterday in Slack to Francis Potter. I'll link it into this notes doc where I talk about that. Basically, there's a couple different ways to distribute GitLab HA and set it up. And we are working on what we're trying to define now, what we're calling the 10K reference architecture. That will be the diagram that you'd basically want to be looking forward to. But I'm sure there are a bunch of other customers in the wild that have subtly different variants of that. So 10K reference architecture document. I'll link to my answer to Francis yesterday, which outlines a little bit more. And I think that that will help. And then from there, Any further questions you have, we could take offline. How's that sound?
Sounds great.
Cool. Awesome. Any other questions from the team? Great question, Mike. I appreciate it.
Hey Lee, question, and thank you.
Yep.
This is already wonderful. Okay, so you said workhorse was developed by GitLab, so that's just a GitLab tool. What about Unicorn? I don't know much about that.
Sure. So Unicorn is an open source project that is many Rails applications use Unicorn. Workhorse was developed in-house. We have a blog post about it that was written a few years back. If you want to read more about the very specifics of Workhorse itself, if anybody knows that blog post, you can link it in the doc. And Chrissy, I'm going to encourage you to put your question in there as well, just so that we have it recorded. So people can comment, and I'll put some more notes. But Unicorn is a open source project. I do want to take that moment to say Unicorn will be going away in theory. And you're like, huh? What? It's the heart of GitLab. We have proposed switching to another technology called Puma. And Puma versus Unicorn have subtle differences in the way that they work. Their ultimate goal is to serve the Rails application, to serve the code that we've written. But Unicorn and Puma do that differently. I'll describe it like this, and then we could talk about it more later. Unicorn uses a worker model, and Puma uses a thread-based model to handle the requests, which have different trade-offs and different things. The main reason we would want to switch to Puma is for memory consumption. I'm sure you've seen a lot of people say GitLab uses a ton of memory because we use Ruby, because we use Unicorn. We're trying to shift that a bit. But Christy, I hope that helps. Any other questions from the team? All right, I'm going to move on to the next section here where we start to dive into debugging Unicorn itself. So Unicorn will log its errors to a folder or a file, called Unicorn Standard Error Log. On a default GitLab install, that will be var log GitLab Unicorn Standard Error Log. If they're doing anything crazy, it'll be somewhere else, but the file you're looking for is Unicorn Standard Error Log. Now, I have taken the two types of errors that you'll generally see in that log here. There's a third type that would be related to LDAP, but it's more of just a warning, not an error. The two big things that you want to think about, you have timeouts and memory killer. And I'm going to talk to them and how they work a little bit. So, for example, we have this here. This is a timeout in the Unicorn Standard Error Log. We see that worker number 2 in this instance timed out. 4 seconds is greater than 3 seconds, so it killed it. It shows us that it killed the worker, and then the worker is back up and ready. So that is a timeout. Now, I'm going to talk more about that. We have memory killer, which memory killer, we can see a very similar structure. Warning, the worker, the process ID here, exceeds memory limit. They give us the bytes is bigger than this amount of bytes. We're going to kill this worker with this process ID, 5687. It's been alive for 645 seconds. We've killed it, and now we know that that worker was worker number 3. Worker number 3 is ready. Now you're saying, okay, well, what does this mean actually? What is happening? Why is Unicorn killing things? What does that mean? So we're going to take a second to talk about Unicorn and how it works. Unicorn itself will spawn worker processes. And depending on how many CPUs you have on the server, we recommend adding 2 more processes than the amount of CPUs you have. So if you have 16 CPUs, we want you to have 18 worker processes. What does that mean? That means there are 18 instances of GitLab, the Rails application, running, each one of those in Unicorn. Each Unicorn process will handle web requests that come in. So as a request comes in, worker number 2 will pick it up. And the next request comes in, worker number 3 is going to pick it up. Next request comes in, worker number 4 is going to pick it up. And they'll go on and on and on and ad infinitum. Now what happens is, depending on what the request is doing. For example, if you want to load an MR page that has 20,000 comments, we have to go and find those comments in the DB. We have to render them. We have to do all of this stuff. If that code that is running takes longer than the timeout that we set, then Unicorn will kill that request. Kill that worker, which will end up with that request failing. We've seen this happen. I'm sure you've experienced it. What that does is allows Unicorn workers to not get tied up forever. Imagine a scenario where if you have 18 workers, that means at any given time you can be handling 18 things. If 18 people try and load that page with 20,000 MRs and we don't use a timeout, it will just fill up the whole server. The further requests will fail. They'll queue up. The service will be degraded. GitLab is still there and running. It's just now no longer available to the people who want to access it after those 18. So that's where timeouts come in. Now, memory killer is a very similar type of thing where each Unicorn process, as it does work, it may need memory. If you're loading 20,000 comments, you're grabbing them from the DB, you're trying to render, you're going to need to grab some memory. Now, we have memory killer in place so that it doesn't add system instability. And you're saying, well, what does that mean? If a Unicorn process needs more memory, it will grab it. After a certain point, the system might not have more memory. Then you have a process in Linux called the killer, out of memory killer. And what the Unicorn memory killer is trying to be more aggressive than the killer. Because what happens is on a Linux-based system, the killer will just kill what it thinks is best. And that might mean a service that we really don't want to go away. So we're saying we'll self-police Unicorn, we'll try and keep an eye out. Now, with that, these two values are tweakable, but they come with caveats. For example, in an HA environment, if you're running a node that is just running Unicorn, then you can probably raise your Unicorn memory limits pretty high, depending on what else is running on that box. But if it's just Unicorn, you can raise those up to take the amount of RAM that you have available because nothing else is going to be competing with it. That's something you could do. What that means, though, is there are some requests that could balloon and use a ton of resources. That's okay if you have the resources available to you. If you don't, then you want to make sure that we protect it. Same with timeouts. You can raise a timeout, but what that means is for those requests that would have been timeout killed, you are now going to just take longer. That's a bad experience. So we tell our customers sometimes during debugging, we will temporarily raise timeouts, see what we can do, and then try and reduce them back down to the defaults. There are some instances where you may raise a timeout, it will generate the page, cache the data that it needs, you can lower the timeout, and future requests will be fine. Then you could talk to support engineering and things like that, and we could try and understand why in their instance did we need more time. Right? Was it lack of CPU speed? Was it they didn't have enough resources? Was it some other thing that was just so slow? Or was it the code was not optimized as well as it should have been? So those are some of the ways and things that you'll see in Unicorn Standard Error Log. If you're raising timeouts, you want to do it temporarily. Otherwise, be ready for requests to potentially take longer. And for Memory Killer, if you have a dedicated node running Unicorn, you can raise that up to use available resources. But if not, it's meant to protect the other resources so that Unicorn doesn't get too greedy. So I'm going to pause for this second. Any other questions, thoughts on here before I move on to talking about a few other things? I see a hand raised. Go for it.
So how do you raise the timeouts? Is that in the UI or is that in the GitLab RB?
So that's a great question. There may be an option to raise the timeout in the UI now. I would recommend the RB is how we in support engineering traditionally do it.
So that requires a reconfigure, correct?
Correct.
So downtime in
Correct.
theory.
That depending on your setup. So for example, there are ways in which you can get more advanced where you can raise the timeout and then have Unicorn do a rolling restart. There are ways to do rolling restarts in theory, but again, it depends on the needs, depends on the client. In an HA install, if we were doing that, if they have other nodes, then that restart of one node should be fine. But yes, to be very clear, a reconfigure and the basic case would require downtime. It will flush connections and restart Unicorn.
Okay, so you mentioned in the HA environment, if you did this on one node, that would be sufficient for the whole system or just for that node?
So so this is where it gets tricky and depends on how clients are managing their HA installs. If they're using Chef, Puppet, or something like that to manage their installs, then effectively we want to tell them they can roll it out and do a rolling one node at a time to make sure that the whole Unicorn layer doesn't go down. If they're doing it by hand, you can log into a one node and then target your request to that node. Say, for example, if you have web front end number 3 and you raise the timeout and you go to web front end number 3 and do your request there. So that's a possibility. If they're using Kubernetes, Kubernetes will do it all automagically. But yes, so it will, depending on your goal, right? If your goal is we want the entire timeout to be raised across the board, then you have to roll everything and restart. If you want to test, you can pick one node, target your request to that node, and then test from there. Awesome, got a thumbs up. Any other questions on this section? Any other thoughts before I move on? This will tie into more deeper as we go on. It makes sense, it'll kind of build onto it, but I want to just make sure if anybody has anything else, we'll. All right, not seeing any movement, so I'll go on to the next bit here. Now, this next slide, this next section is Unicorn errors, and I have in parentheses workhorse. Workhorse is separate from Unicorn, but they work in unison, and the requests that every request that go to Unicorn are gonna, let me rephrase that. Let me think about this. Let me make sure I say this correctly. When someone is trying to access a GitLab resource, yes, every request should make its way through workhorse. So this is a huge input zone where you can get a lot of information, right? And it sits in front of Unicorn, and it will route some of those requests to Unicorn. It will route some of them to other resources. And what I want to focus on here is this debugging trick. And this came about recently. We figured this out. I went on a spirit quest to try and add into Unicorn. I wanted to make it tell me what the request Unicorn was working on in this output. It's very hard to do, near impossible. But when I was working and talking with Stan, we figured out that actually the way that this will be bubbled up, or you'll see it, is in the workhorse log. You'll see this error message, bad gateway. So for example, for this request here, failed after 5 seconds, end of file message get, method get URI /. This was when I timed out. This is what I saw in Unicorn. So basically you can look at 5 to 10 seconds or however long your timeout is, maybe a minute, 30 seconds before your reap message in Unicorn error log, and you'll find out what the person was hitting. This is really valuable because now you have potentially a reproducible thing. As we think about GitLab, it is a system, an ecosystem, an organism that it could be under heavy load. And for example, if I timed out because resources were constrained or something like that, and I retry this request in 5 minutes and it works, now I say, that was slightly non-deterministic behavior. What was different? Okay, it's probably load. If I try this again in 5 minutes and it still fails, and I try it again in 10 minutes and it still fails, now you're like, okay, I've done this 3 times, it fails every time. This looks like a bug or a problem that we need to get to the bottom of, not related to load. As you're working through and thinking about GitLab, those are the 2 thoughts a support engineer has. Is this problem related to load in any way, or is this an actual bug or processing problem? And this is where we see those errors in workhorse. Now, I'm going to point to workhorse. One of the most interesting pieces here that we'll dive into a little bit more as we work our way into the stack is 500 errors, right? And how and where they get generated. So if you think about GitLab as a stack of software, you have Nginx in the front, behind that workhorse, and then you have Unicorn, which handles Rails. So Nginx, workhorse, Unicorn. These are your web requests. These are things on port 80443 are going to go here. The other type of request you would see would be an SSH request, which would be used for Git data or things like that. So what I'm saying here is, for example, if Unicorn has a timeout or a memory kill, that process goes away. It's going to bubble up to Workhorse, and Workhorse is going to see that end of file error. Workhorse is going to say, well, the thing you tried to get, we had an error. Then it's going to bubble up to Nginx, and Nginx will say, well, the person behind me had a problem, and this is what they told me, and they're going to show it to the user. So in the stack, basically Unicorn, Workhorse, Nginx is where you're going to find where the errors come from. 99% of the time, it's going to start with Unicorn. Very, very, very rarely do we see a problem where it's like Workhorse was gone, because Workhorse is pretty stable. It doesn't do much. It's a very simple router proxy. It's not a heavy lifter. It just acts very quickly, right? And then Nginx sits in front of there as well to be very efficient at handling and queuing requests. So sometimes, depending on your errors, you'll see it generated from subtly different spots in that stack, but those are the hot spots, right? Now notice in my discussion, we've focused on Unicorn because it's the heart and it's where we get a lot of problems. A lot of these other pieces can have problems, but they're usually not showstoppers, right? They're subsystems or all sub processes that are doing things, but aren't usually going to take the whole thing down. This kind of stack here, and I'll talk a little bit more about Gitaly, this kind of 4-process stack are the huge pieces that are heavy lifters, heavy process, heavy spots where that's where you're going to see a lot of problems. Now, I want to move forward to talk about 500 errors, which is what I mentioned. The 3 that you're usually going to see in GitLab, 502, 503, or 500s. And I'll talk to each one of those, right? So for example, if you get a 502 in GitLab, and you probably have seen this at various points, maybe with clients, or the classic spot that you'll see this is if you restart a GitLab server and go to the URL, so gitlabtesting.com or wherever your URL is, you're probably going to see a 502 if you just do it real fast. Why is that? Well, what happens is when you're bringing up GitLab and it restarts everything, Nginx is super fast to start up. It's really fast. It's really efficient. It knows what it needs, and it's done. It's ready. Workhorse is probably up next and pretty quickly. Well, Unicorn, if you have 18 processes that need to load probably close to a gig each of resources, to set up that takes time. So when you see that 502, it usually means Unicorn's not available. Now you have to ask yourself, well, why? Well, like I said, if you generated the restart, well, it's restarting. But it's also possible that the Unicorn killer killed it, or it had a timeout or something along those lines. That could be a reason why you're seeing a 502, right? And that's why sometimes some people will see 502s and others won't, because their request, the worker that was handling their request went away, and they're going to get a 502. Now, there is a very unlikely chance where for some reason you have completely saturated your system. Unicorns are 100% loaded. They can't handle anything. Nginx is sending requests through Workhorse. Workhorse is trying to get to Unicorn and it can't, and it'll generate a 502. But that's very unlikely in the wild. That's very rare that I've seen that happen. Usually the failure mode is much more Unicorn workers are restarting very frequently. Some requests are getting through. It's kind of slow, but you're not going to see that 100% saturation. It'll just be very constrained, and you'll see a lot of errors in the log. Now, this one, 503, GitLab itself doesn't throw this that I've seen. What I see this come from is the load balancer in front of GitLab is down, or load balancer is somehow misconfigured. this error message, right? If you're running a distributed system or some other type of server in front of GitLab, if GitLab as a whole, the entire organism is gone, then you're going to see that 503. So you'll rarely see 503s unless the whole service is down. At that point, it's like, you know something is wrong. Or if you don't, and you're like, hey, GitLab threw a 503, then it's like, okay, the balancer tried to talk to GitLab, tried to talk to Nginx, and Nginx wasn't there. If that's the case, then you have to figure out why it thinks Nginx isn't there. Because if we think about this process stack, right, Nginx to Workhorse to Unicorn, Gitly, Nginx, extremely stable, rock solid, very rarely a problem unless you have it misconfigured. Workhorse, very rarely a problem unless it's misconfigured. Unicorn, heavy lifting, so it's breathing heavy. It can be exhausted at various times. That's possible. So those are kind of the errors. And then the last one is the 500, which you've probably also seen, which means there's a logic error in the application. These are very easy to debug because if you go to the production log, you could see the error message. It will throw it out, and you'll want to get that full trace over to support, because then we could say if we've seen it before or we haven't, or this is new, or it will tell us exactly what the problem is. So it makes it very, very, very clear. I want to take a second to pause here. 500 errors, kind of that stack with Nginx, Workhorse, Unicorn. We're about to start talking about Gitly. Thoughts, questions, ideas, concerns? All right.
Actually,
Okay.
Lee, question, and
Yep.
I'll write it in the doc. So one thing you mentioned, the full production log when there's this error,
Mhm.
and I know sometimes, like I feel like with relaying this back to the CS team, what would like be the base sentence you would want us to share when, say, a customer is saying, I have this 500 error? Would we say, please share your full production log with support
Sure.
when you submit a ticket?
I'll talk to that a little bit later.
Okay.
But if the customer is savvy, I'm going to take a moment. I'll share this theory I've been working on. I'm doing some conference talks later, and I'm trying to like come up with this theory that is like the premise of support engineering at GitLab, where I think there are two types of customers. You have a customer that are sharp, and you have customers that are scared, right? Well, let's think about how we define that. We know the sharp customers. They're customers that they're probably doing something advanced. They seem very comfortable probably with the command line. They seem very comfortable with GitLab as the ecosystem, right? They understand the stack and how that kind of fits together. Those customers are bringing you ideas, right? Then you have the scared customers. They may know a little bit about GitLab. They may know about what Nginx is, but they feel scared to touch it because they're scared if they touch it, they're going to break it, right? And those customers, depending on if you have a sharp or scared customer, is probably going to change the answer, right? So the safe answer is you can ask them, hey, give us the production log. If they're in an HA environment, we need all of the production logs, right? We need to be able to see everything. If they are a sharp customer, you could probably pinpoint and say, hey, hit that page, generate the in your production log at that time, you should see an error message, paste us that full stack trace, and that should be a plenty for support. And a sharp customer should know exactly what that means and how to do that. Now, with that theory in support engineering, we're trying to figure out, well, how do we turn scared customers into sharp customers? Because the sharp customers are fun to work with. The scared customers are hard to work with because they're scared. Anybody that's scared is hard to work with. So that's kind of Lee's meta theory here. Long answer to an easy question.
I think that's
Other questions? Oh, go ahead.
I think that's a great generalization and good fodder for a conference talk.
Thanks. I'm trying to make it work. It's going to be interesting, but yeah, trying to figure out, how do we make that work? I'm going to move on to Gitly if there are no objections. All right. Scenario: deadline exceeded. So now this is Gitly. This is an extremely important part of GitLab. It shares the name Git in the name, Gitly. So you can understand that this is probably doing something very important. If you're not familiar with Gitly, we have a lot of information out there around Gitly, you can go to the architecture page. You can click on the Gitly in the sidebar. You could see where our documentation is, our motivation, blog posts, stories, theories. Effectively, Gitly will sometimes throw you this error: deadline exceeded. You'll find this in the Gitly folder in the current error directory, file. So var log GitLab Gitly current is the file name. And you'll see a line that looks like this: warning, health check failed. It will give you an RPC. It'll tell you deadline exceeded, and then it'll tell you the worker that was working on it. Now you're like, what the heck is a deadline exceeded? This is another case of self-inflicted GitLab trying to make sure that it doesn't destroy itself. It is saying, this took too long. I'm going to stop working on that, and I'm going to start doing other things. Now, for example, if you are going and you're working in GitLab and you go to that Gitly current log and it's flooded with deadline exceeded, well, now you probably have a problem where you're down, where things are all breaking, those kind of things. If that's happening, then the issue is we are struggling to get access to disk, right? It is taking too long to get to the disk, whether that's network or the hard drives themselves. We cannot get the data fast enough. There are 3 Gitly deadlines. You'll see them in the UI. They are tweakable, but you do not want to tweak them higher, because all that does is say, okay, you can be slower, and effectively every request now can be slower. So what you've done is you've solved the problem by you're not going to see deadline exceeded anymore. But deadline exceeding is kind of a flag to say, hey, go see why your disks are slow, right? You don't want to say, well, I have deadline exceeded, how do I get rid of this error? That's not the right thing. The right thing to say is, I have deadline exceeded, why is this slow, right? And then when you understand that, the deadline exceeded will go away because you've solved the problem for them being slow. And I just want to pinpoint there those 3. We have Gitly deadline fast, normal, and I think we call it long or slow. Effectively, we've done some research and we said some Git commands should be really fast. Some take a little more time, some take a lot of time. And we've structured that in that way so that we can fail even faster, so that GitLab can be more reliable. It seems counterintuitive, and a lot of customers that aren't used to thinking about software at scale are not used to that thinking, where it's like, if we fail a specific number of slow requests, we may have better uptime. And it's like, oh yeah, fascinating. So that's deadline exceeded. That can bubble up, right? If Gitly is slow, that can potentially cause your unicorn process to be slow because it's waiting on Gitly, and that could bubble up, give you other errors, 502s and things like that, possibly, right? So now we've kind of worked our way all the way to the back of the stack to the bottom, Gitly on that base layer, giving you deadline exceeded. Now, with that, Gitly is tied into a couple of other systems, right? Those deadline exceeded errors may show up in other logs, right? You can see a deadline exceeded sometimes pop up in a unicorn log, in a production.log, or you could see Gitly time deadline exceeded. I've seen them pop up sometimes in CI runner logs, right? Because the runner was doing some things and then deadline exceeded, so it bubbled up the error message. So you could see it in other places, but if you see that deadline exceeded, the disk access for Git data was too slow. As a temporary measure for an extreme stopgap, if it's everything's on fire, we just need to get this one release out, you can raise those timeouts. Otherwise, raising those timeouts are going to cause massive amounts of pain. They're going to cause suffering, plight, drought. The locusts will come, like all of it. So don't dare do it unless you're doing it for 5 minutes, because the release is blocked completely. You just need to get the release out, and then you're going to go and immediately figure out why the disks are slow. So that's Gitly, that's deadline exceeded. That's really the main error message you're going to see from Gitly, the most valuable, most important. Questions or thoughts on that before we move on to Sidekick? I saw the chat bubble up, so I just want to make sure nothing important in there. If Zoom will render me chat. I lost it. There we go. Cool. So nothing that is needed to be answered in the chat. We'll go on to Sidekick. Notice we haven't talked about Sidekick yet, but we will. I'm going to pop into an architecture break and point over to Sidekick, right? Well, what the heck is Sidekick? Well, it hangs off to the side. Sidekick handles a lot of background processing. This is designed so that GitLab requests can be even faster. Well, how do you do that? Well, you do it asynchronously. Imagine, for example, if you had to render the MR page in Unicorn. If you're doing that, synchronously, you got to load it all in, do all of this, blah. If you take some of that and say, hey, I'm going to do some of this asynchronously and report back, now you can go and you could throw that off to Sidekick, and then when Sidekick's done, it can send it back, and it's not going to waste time. So that's the possibility of what Sidekick gives to you. I'm going to come back here. It logs to the Sidekick folder, the current file in there. So when a Sidekick job fails, it should give you a stack trace. It should say, failed, this thing, this is what we did, this is what happened. When that happens, you throw us that stack trace and support can start to debug. If you are enterprising, you can go and see, it should tell you what worker it was working on. And for example, you can see in GitLab how many workers we have. These are background. These are all of the things that we background process in GitLab, right? At any given time, GitLab is handling all of these things in the background, whether on a schedule or ad hoc, depending on load. It is doing all of this. So for example, if you had a new issue worker fail, it would be new issue worker failed because blah, and you could come in here and you would say, well, it probably failed on one of these three. It would tell you, and it might say like, can't send the notification because the DB's down, and you're like, oh wow, okay, there we go. But you can start to check out what Sidekick is doing. There's one last thing I want to share about Sidekick itself. Sidekick has some modes where you might see failed and dead processes, jobs. Sidekick calls them jobs, failed or dead. A failed job will retry by default 5 times. Depending on the job, it may be subtly adjusted. If a job is dead, then that means it's done retrying. It's not going to do it anymore. Now, what I want to say here is the way that Sidekick is set up and works. For example, if you do something, it does it in the background and it fails, you're usually going to see it in the UI somehow. Whatever you were trying to do is not going to be there. So that raises the question, why did Sidekick fail? If it was load related or whatnot, you kind of do that retry loop. Retry, if it works, okay, wow, okay, interesting. Some kind of load caused Sidekick to not be able to process this. If you do it again and it fails, okay, now it seems like Sidekick is probably having a logic error. So we need to go look in the logs. We need to go see what errors we find. So if we do that, that will give you some examples. So failed jobs aren't the end of the world. Dead jobs are also not the end of the world, because if a job is dead and you as the person are like not getting what you want, you're going to keep trying, or you're going to ask support, or we're going to figure out why it died, right? So it's one of those things where it's not the end of the world, where if you see a failed or dead job, usually you're going to continue to do the thing, and we're going to either fail again or figure out why it failed. So those are my musings on Sidekick. It is often can be a bottleneck, right? It's something that we want to manage, and depending on how you architect the setup for a GitLab install, we usually separate Unicorn and Sidekick to try and let background jobs do their thing, let the front end be decoupled so they're not fighting for resources. But beyond that, Unicorn is relatively stable. I don't usually see it running into problems. But you can have Unicorn failed jobs and things like that where we have to tune our code and our logic. So thoughts, questions before I move on to the next section? All right, we're gonna do it. So this goes back to the earlier question. Here's a scenario when the customer does not give us a clear problem description. This is the worst. This kills the support. This is not fun for us. So when you're working with customers, feel free to share this deck with them. Feel free to share this video with them. Let them know, like, we want them to get as close to the problem as possible. Now, there are times where they may not know, and that's okay. That's what we're here for. But the more that they can give us pinpoint or the more clarity, the faster we'll work. We also want to understand their architecture and relevant logs so they can pass them over. We built a tool called GitLab SOS that customers can use. If they're a scared customer, GitLab SOS is going to be their best friend. GitLab SOS is something they can run. It bundles it up, gives us a zip file. They can send it over to us, and it gives us everything that we want to know. Really, really helpful. Sharp customers use it as well, but sometimes a Sharp customer will look at the output and then say, hey, in my SOS output, this looks interesting. That's awesome. That's what we want more of. We can't expect that all the time, but the more customers we can get understanding how GitLab works, the better experience they're going to have, because it's not going to be a giant black box. It should be a giant glass box. They should be able to see and understand what's going on inside. So we want to get those stack traces because they're super valuable, because without a log message or error message, we're just in the dark. For example, we see this happen all the time. We're seeing a 500 error when we visit this repo, and then they send us an image in a Google Doc, not even a Word doc, with a 500 error page. This gave us no data, right? We know nothing. What is the dream? What would I love to see? We are seeing a 500 error when we visit this URL. Give us the URL. We've looked in the production log. We found the trace for that URL. Here's the trace. Now, when we have that, we can immediately get to work and say, we've seen this before. Have we not? Do we have ideas? Potentially, if we know the problem, fix it, solve it, point them to where it was fixed. And this could be a one-touch resolution. You know, this is super, super valuable. Anybody can do it the other way at any given time. You know, it's very easy to do this and when you're scared and in a rush. But we encourage customers to kind of take that 30 minutes, take that 3-step try, right? Try and understand, is this load related? Is this a bug? Have you found the error message? We are doing as much as we can to surface that. And as we surface that, that makes it really easy for us to debug. So I'm going to move on to some more theoretical questions. This was my scenarios that customers will often run into that will cause problems and how to think about them. Unicorn, Giddily, Sidekick, Unclear problem descriptions are the top 4 things that support deals with. And if we can get more clarity on those from the customer, we'll be able to help them much, much faster. So questions on that before I move on to kind of talking about some meta GitLab related things.
Yeah, thanks.
All right.
That was really good. But I think we should, unless there are questions, we have about 12 minutes left. So.
Okay, great. I can blow through this last 3 sections really, really fast and probably have about 5 minutes left for questions. So customers often, if they're sharp, say, GitLab's running Postgres. Like, I could just talk to Postgres and get stuff and do that. And dangerous, right? Very dangerous. We want to tell customers, try and use our API. If it doesn't exist, especially if you're talking to TAM or customer success in any way, hey, tell us what you need from the API. Support engineers have been making a lot of contributions to the API recently to try and make it more robust. If they're in a rush or they need something, DB queries, reading from the DB, that's safe. You can read from the DB and I'm not worried about you. If you try and edit DB correctly, I will haunt you forever. So tell them, don't do it, because, example, if you change something in the DB and GitLab doesn't know, GitLab often has a lot of cascading things that if a value gets changed and in the app does it, it will do some other things. If you just change in the DB, those other things may not trigger or fire, and that's a nightmare, which is oftentimes why support engineers will use the Rails console, try and use as much of the app to trigger those auxiliary effects, if you will. But we don't want customers in the Rails console by themselves unless they're sharp and they have a subset of commands and they know what they're doing, or we told them, hey, run this command, it's just read only, or hey, run this command, it's dangerous, we vetted it, know the dangers, but like you need to run this. And so that's on thinking about getting data out of GitLab. Moving on into integrations, customers often integrate with GitLab. One of the biggest things that I think about is if the integration is there, 85% of the time it works. But the problem is the person who set it up isn't there anymore. They don't know how it works. They don't know how it's documented. We have about 3 different, subtly different ways to integrate Jira and other tools like Jenkins and things like that. Depending on how that's set up, you want to make sure that the customer knows how their integration is working and what it provides. The other bit is they'll upgrade the integration without thinking about the implications for GitLab. And then if there's a version mismatch or some feature disparity that causes problems, it's not something that we did. It's just we need to work with you and understand. Don't willy-nilly upgrade. And if you want to think about integrations and doing that, your TAM is probably the best spot to start if you have a TAM, because we want to understand what you're doing and figure out how you're integrating. But very, very rarely do integration bugs live on, because it either works or it doesn't, and we know about it, and support needs to fix it, because if not, we're going to deal with it forever. So we think about scalability, and we had some questions earlier about HA. When we think about this architecture, you can divvy it up many, many, many different ways. But the things that you kind of want to think about as you're doing that, when it comes to scale, performance, and stability, these kind of 3-pronged triangle, right? The number one thing that is going to give you GitLab performance, because we're using Git and we need to access Git data, is going to be disk speed. You want your Git layer to be blazing fast. The faster you can get it, the speedier you can do that, the best performance you're going to get bubbling up. Then from there, when you're thinking about the Rails app, you want a fair bit of CPU and spread out so that you can get those concurrent requests in. Right? When you're thinking about pure performance, again, it's the same thing. Fastest disk, the biggest amount of CPUs you can throw in there and that you can afford, and the widest you want to go will let you get more performance. Again, depending on the constraints is going to dictate what they get. We in support just built this new tool we're calling Fast Stats. We're trying to benchmark, and we're going to be working with customer success on this. Every version from here forward, we're going to have a benchmark from GitLab.com, and we want to compare customers to GitLab.com, and we hope that they're within 10% of GitLab.com speeds, right? And where they differ, then we can pinpoint and understand more about their environment. Oh, why is this section slow? What is the differences? Data-driven decision-making is where we're trying to get to. Our customers are resonating with this. It's working really well, so we're trying to deliver on that. And then when it comes to stability, if we think about this graph, stability is really dictated by resource contention, right? If everything is isolated from each other, now you've resolved that. And if everything has enough resources, then you will be stable, right? If you have stable ground and you're not fighting with anybody, there's stability by default. Where things start to shift to depend on volume and things like that. But again, if your disk is not consistent and erratic, or your CPU is constantly under load from virus scanners or other software doing things, that's going to dictate stability. And if you have load that shifts or ebbs or flows or things like that, that can change your stability. We need to think about this as one element doing that all together, because it's, you got to pull it in subtly different ways to figure out what you want or need. And the last thing I want to share is some relevant dashboards from GitLab.com. Customers are always trying to understand, what are we doing on .com? The biggest thing that I want to tell customers is, you may be GitLab.com. A lot of our customers don't have the team or the scale or the need to be GitLab.com. So the thinking and the things that we're doing there might not make sense. For example, we have these rules for thresholds for alerting. For GitLab.com, those thresholds may be insanely high for one instance where a customer has less than 100th of our volume. So it's one of these things where keeping that in mind, where there is a lot to learn and there are a lot of things that you could see what we're paying attention to, but you also don't want to make this the end all be all. We're going to use it for performance, right? Because we want to make GitLab.com the pinnacle of performance. But from there, customers may not need all of the things that we're monitoring on GitLab.com or whatnot, and it doesn't make sense to try and model their infra after it. But as long as their infra is as fast as it, then their experience is as good as we can promise. So, questions?
Thank you, Lee. That was really awesome. Just real quick question on that last slide. As far as Grafana dashboards, when you load up Grafana for the first time, now that we package it with Omnibus, does it come with like some default metrics to begin observing, or do you need to install the config to get all the metrics all set up?
Yeah, so it depends, right? My understanding right now is we have, depending on the customer, if they don't have Grafana bundled in and that startup experience, I don't know exactly what it looks like now. But what I do know is that we do have this export of our Grafana dashboards that they can grab. And then we have what we call the omnibus dashboards, which aren't linked here, that they should be able to directly import and should just work. If you're finding that that's not happening, then we need to work with the monitoring group, because that's our vision. But going forward, I think from probably, I'm going to imagine 12.2 or something, Grafana out of the box should be pretty robust and make it really easy. Grafana, Prometheus, all of that should be really straightforward for customers. So does that help to answer?
Yes, but the big takeaway is if they do reuse the Grafana that we've published for .com, they just need to understand that those thresholds are scaled to .com, and that might not necessarily be relevant.
Exactly. Those thresholds might be scaled. Also, for example, the .com dashboards have some .com specific things in them with the routing and the way that they're rendered, so they might error out on first try, whereas the Omnibus dashboards are designed to work generically for an Omnibus install, and that should work very smooth. So we're trying to make those Omnibus ones that we load in by default work, and the .com ones will be the ones that will they may have to tweak, but anything useful from .com will probably land on those Omnibus ones anyway. So support is really trying to drive forward with using the graphing, the Grafana, data-driven, because, for example, a customer will say, GitLab is slow. GitLab is 31 plus components. What is slow? Where is the slowness? What are you experiencing? Because we need to pinpoint and understand how, where, why, what, So other questions, other thoughts, team?
Not so much for you, but more just for the documentation that goes along with this. Can we, Latsy, can we link to the Omnibus Grafana dashboards? Lee mentioned some documentation for that. Let's make sure we include that in our documentation.
Yeah, totally. And I'll see if I can add it to this slide deck just for reference. But it will be, I don't know where they're at off the top of my head, but I'll see if I can find them.
Okay. Yeah, no, this was great, Lee. I really appreciated this. It was a really good deep dive and really helps.
This is close to 3 years worth of GitLab knowledge, experience, and exposure bundled into one jam-packed hour. Hopefully it was helpful. I'm glad. Thank you for that. And I'm excited to see what your team can do with this. And we want to try and figure out how we can make all of our customers sharp customers and help them understand where the problems might be. Because as they do that, that's going to make our lives better. And the faster we make that loop, support engineers will write and fix bugs and scaling problems and things like that. So it doesn't even always have to go to product. We want to be a resolution center to help customers as well. So there's a lot of value in getting them up to speed so we can run really fast. So cool, everyone. If that's the case, enjoy your Tuesday. Thank you so much for your time. I hope you had a good one. And if you have any other questions, feel free to come into support team chat or support managers channel in Slack, and we're happy to answer whatever we can. We love working and partnering with y'all because you're great, and we want to make sure our customers get what they need.
Awesome. Thank you, Lee. And this is available to our organization in our Google Drive, but we will also get it up on GitLab unfiltered once we take a look at the nuts. But I think we're all good. Everyone-
Perfect. Bye all. Nuts.com.